Hi everyone, welcome to the next video in this series of videos on angles of polygons. This one we're going to look at some example problems of the polygon interior angle sum theorem and just kind of see how this can be used in different problems. So what we're going to do first is kind of just a basic using the formula, if you remember from the last video. Our formula for this would be the n minus 2 times 180 degrees. So that's our formula for finding the sum of the interior angles of any polygon. So this says find the sum of the interior angles of a nonagon. The nonagon has 9 sides. So what we would do is just simply say, well, I want to use this formula for when n is equal to 9. So that would be a 9 minus 2 times 180 degrees. So basically 7 times 180 degrees. And I don't know what that is off the top of my head. So if I pull up a calculator, I'm just going to do 7 times 180. And I get 1260. Alright, so then that sum would be 1260 degrees inside of every 9-sided polygon, convex nonagon. Okay, so that's basically the basics of how the interior angles sum formula is going to work. Now, if we look at a little more advanced problem, this one we have a pentagon. We're given 4 of the angles, and we're asked to find the 5th angle, or the missing angle, x. All right. So we're going to start off by using the formula again to find out, well, what should our total be? So what should our sum for 5 sides be? So if we plug that in, we'll get 5 minus 2 times 180, all right? And then that would be 3 times 180, or 540 degrees. So we know that when we add all of these together, it has to be 540 degrees. So from that, we're going to subtract the sum of the 4 angles that we know. So we're going to subtract 110 plus 110 plus 90 plus 80. All right, so when we subtract all of that, pull up the calculator again. So I'll have 540 minus, and I'm just going to add those up inside parentheses. So I'm just subtracting the sum that I have for the 4 angles that I know from what the total should be. So when I do that, I end up with 150 degrees. So x is equal to 540 minus that sum, or x equals 150 degrees. And so that's basically what all of your interior angle sum theorem problems are going to look like for non-regular polygon. Then this video, I'm going to go ahead and jump into a regular polygon. So if we go on to the next screen. So a regular polygon is a polygon that has all sides the same length. So, if we think about some common regular polygons, one of the most common ones is regular quadrilateral, which ends up being a square. Okay? All right, so that would be a regular quadrilateral. So a square is a regular polygon. Then if we look at regular pentagon, has 5 sides, all congruent. Well, if all the sides are congruent, that also means that all of the angles are congruent. We can still use the n minus 2 times 180 to get our sum, or our total, for the interior angles. But now, if we wanted to know, well, what is the measure of just one of those angles, then we would take our sum the sum of your angles that we could find using n minus 2 times 180 and divide that by n, or the number of sides. Right? So I guess just to be a little more specific, we'll just put number of sides down here. So we're dividing the sum of the angles by the number of sides, and we can figure out just what one angle measure is. So for example, this regular pentagon, we know that, if we use our formula, 5 minus 2 times 180, 3 times 180 degrees, we know that the 5 angles have to add up to 540 degrees. So if we divide that 540 degrees by 5, it'll tell us what each one is. So 500 degrees divided by 5, we end up with each angle being 105 degrees. So x would be 105 degrees. Okay? So that's an example of a regular polygon, and that would work with any regular polygon. So if we were to look at regular, what shape is this? So 1, 2, 3, 4, 5, 6, 7, 8. It's a regular octagon. So we're going to do the n minus 2 times 180. So this one is, number of sides is 8. So I would have 8 minus 2 times 180 degrees. Then 6 times 180 degrees. So that's going to be a 0. 6 times 8 is 48. 4. So I believe that's 1,080 degrees total if we were to add 1, 2, 3, 4, 5, 6, 7, 8 angles. All right, so total is 1,080 degrees inside this regular octagon. Now, if I wanted to know just one of them, so if I wanted to know just what x is, then I would take that sum, divide that by the number of sides. So 1,080 divided by 8. Okay, so 1080 divided by 8. I get 135 degrees. So then x, in this case, each of these angles inside a regular octagon is going to be 135 degrees. And that's how you would relate that formula back to regular polygons. All right? Thanks for watching. I hope you liked what you saw. If you enjoyed this video, if you learned something, leave a comment, hit that like button, give me a thumbs up. Stick around for the exterior angle theorem, and we'll kind of look at what that means, and then we'll look at some examples of that one. All right, thanks a lot.